Hello everyone, welcome to Chorus Algorithms. So in this channel, I try to help you to come up with some kind of mathematical problem or some kind of logic for a given coding problem first. And from that mathematical problem or that logic, how we can write the solution. So the main idea here is not just go and talk about how to generate the solution. Here the main focus is how we can come up with some kind of mathematical equation or some kind of pattern for a given problem, and from that pattern how we can generate how we can solve the problem. Today we'll be discussing about frog jump problem. So here the main important point what I'm going to emphasize is, if we get such problem, how we can come up with a mathematical equation, and if the mathematical equation's nature is like something like a recursive nature, then how we can implement that using dynamic programming. So here the problem is, a frog is crossing the river and the river is divided into some number of units, and each unit there may or may not exist a stone. Okay, the frog can jump one on a stone, but it must not jump into the water. So this is clear. So in certain intervals there are stones, and jump jump from one stone to another. Okay, now given the list of stones position in sorted ascending order, determine if the frog can cross the river by landing on the last stone. So our what we need to do is that we need to check whether the frog can reach the cross the river or not. Now the frog on the first stone, and assume the first jump must be 1 unit. Okay, so it is saying that the frog will be on the first stone, we can assume. So it means if in the array there is a stone array, in that the frog will be on the first stone. And which means it already made one jump, 1 unit of jump. Now if the frog's last jump was k unit, its next jump must be either k minus 1, k, or k plus 1. Okay, so which means it can from any position, any given position, it can jump to the 3 stones or 3 next locations. Maybe it may be a stone, it may be water. Now what are the 3 possible jump options? One is what is the previous jump it has made. From that it can make a k minus 1 jumps or k jumps or or k plus 1 jumps. So from this I think we can easily generate a mathematical formula. Let's say what it is asking. Let's say I have a function or a frog which is at nth position, and the last jump to reach nth position is let's say k. Then we have what are other options to reach next position, right? So for the next position I can mark it something like f of n plus k minus 1, k minus 1, or f of n plus, this I am doing the forward jump. Okay, this I am doing the forward jump, I am in n plus 1. Then what are the 3 next option available? K and k plus 1, right? Or I can make a jump to n plus k plus 1 comma k plus 1, right? So this is the mathematical function. So now if you look at this function, it has a dynamic nature, right? Now what should be the base condition for this recursive function? It should never fall into a water. So check jump is valid or not, right? That we need to check. And another is never go beyond the boundary, right? Beyond the boundary, which is 0 and length of stones, or more than right? Then if we reached if if the nth is equal to the stones of last stone, means we can return true, right? Okay, so these are the boundary condition. Now let's see how we can implement this. what I'll just take n comma k only for the function. So if if the position, or if this value is n is reached last self dot stone. So if it reaches last stone, we can return true. Now if n goes less than or equal to 0, because we are going to jump from 1, right? Because already told that the frog is on the first stone. Okay, if n less than 0, less than or equal to 0, or n greater than last stone, return false. Now we can use some kind of memorization to optimize this performance. If n comma k in self dot dp, if it is in self dot dp, then return self dot dp of n comma k. So which means it is already there. Now if it is not jumping into water, right? If self dot now if n in self dot, let's say I have stone, I'll keep something called stone to make sure that stone, and to differentiate stone. If n is in stone and self dot stone of n equal to 1, then then we have to set dp of okay, if it is not there, by default we will set it as a false. Then otherwise we will set it self dot rec of what we want to give. This is the function we want to give, right? N plus k minus 1 comma k minus 1, or self dot of n minus 1, then n plus k comma k. Okay, this is not k plus 1, just k, right? Then or self dot rec dot n plus k plus 1 comma k plus 1, then return self dot dp dot n comma k, right? So what we are doing, we are doing this equation. It is this, we are just doing this equation, and we are doing a memorization, and we are doing this jump only if that position is not in the water. If it is not in the water, we are doing the jump. If it is in the water, we are just making it as a false and going forward. Now what are the boundary condition? If we reach the last stone, we are returning. If we are out of bound, we are returning false. Now if it is in the cache, or if it is in the memorization, then we are returning that value. Okay, it's that simple, right? So if it is easy, if you come up with this mathematical equation to writing this function to this logic, it become very easy. Now what we need to do is self dot rec, we need to call with the 1 comma 1 and the return, right? We can just do return here. Now what all things we need to put? Self dot last stone, for comparison we need, which should be stones of length of stones minus 1, stones of -1. So that is the last stone. Then we want one DP array, right? Self of DP. It's a dictionary, and we want to set for each each stone in stones self dot DP of a stone equal to 1, which means it is there. If you call this run, okay, sorry, there is a mistake. I just need a DP is dictionary, and I want one more sentence, self dot stone. DP is for caching, and this is for stone. See, this is fine, and we can submit, I think. Okay, cool. But only thing is that performance is. So in the previous solution, the performance was little less. So if I just made a condition instead of just calling self.rect with 1.1, I just check if 1 is present only in stones, then call self.rect.1. So when I made that, I got a significant performance improvement, and I'm getting now at least close to 80% faster than other solution. Yeah, but the idea here is how we can generate some kind of mathematical equation, and from there how easily we can write code. Thank you for watching.